To review exponential multiplication or multiplication of items with exponentials in it, let's just look at what we did with numbers. If we have 2 cubed times 2 to the 4th, we can multiply 2 cubed, 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16, or 2 to the 4th is 16. We see that's 128. We also see that 128 is 2 to the 7th power. And we notice there that, amazingly enough, 2, if I add the powers, 2 to the 3 plus 4 power is equal to 2 to the 7th power. And I think to myself, is there some rule for monomials having exponents with the same base? And the answer is there certainly is. Let's look at that. If I have x squared times x third, I can write it out that way, and I see that there are 5 x's, so that's x to the 5th. I notice that if I raise x to the 2 plus 3 power, and notice that when I raise it to that power, the 2 plus 3 is written small and up so that there's no mistake that it's not x squared plus 3 or something like that. So when you're writing this yourself, you need to be very careful about how you do the notation so that things that are exponents are written above midline and a little bit smaller. For all exponential forms with the same base, we have this general rule. N to the a power times n to the b power is equal to n to the a plus b power. We notice that if the base is the same, we keep the base and add the exponents. Let's talk about the rule for this. To multiply exponential forms with the same base, we write down the base, then we add the exponents, and if there are coefficients on the two terms, we need to multiply those coefficients. Have to be careful though. Sometimes, as we discussed before, there are terms with no exponents specifically written. When that happens, you assume that the exponent is to the first power. So since 1 plus 5 is 6, r times r to the 5th, or r to the first power times r to the 5th, is equal to r to the 1 plus 5, or r to the 6th. Now, how about multiplying monomials with coefficients and exponents? Let's look at some examples. The rule is we multiply monomials with coefficients and exponents with the same base. We bring the coefficients together and multiply those. Then we bring the exponential terms together and add the exponents for like bases. That's a lot of words. Let's look at how to do it, and it will become very clear, and it's relatively straightforward. We have 5s squared times 3s cubed. Let's follow those rules. 5s squared times 3s cubed. Remember again, when you're multiplying things, the order in which you multiply makes no difference to the answer or to the product. So you can swap them around without hurting anything. You just have to be very careful that when you do this, there are no other operations in the way like addition, subtraction, or maybe even division. So if we look back at the slide, we see we have 5s squared. What does that really mean? It means 5 times s squared, and when we have brackets up against each other, we're still talking about multiplication, so it's times 3 times s cubed. Let me rewrite that by switching the order around, as I suggested we would do in the rule. Then 5 times 3 can be multiplied together to get 15. Now here we use the rule for multiplying like bases with different exponents 2 plus 3 is 5, so the result for this is 15 s to the 5th power. Let's look at another example of this. We have 6x to the 8th power times 2x. We can rewrite it this way, but we need to remember when we see an x by itself, we really mean x to the 1st power. Now, since every term here is multiplied, we can rearrange these to put the coefficients in the front and the two terms with x to different exponents on the right. 6 times 2 is 12. 8 plus 1 is 9. So the final result is 12x to the 9th power. One more example. Minus 8a cubed times 9a to the 5th power. I'm going to hesitate between each statement so that you can do this in your head as I do it. The first thing we need to do is to group the coefficients and the terms with the exponents. I can write that down now as separate multiples, indicating that I know I have a minus 8 times a cubed times 9 times a to the 5th. Then I put the coefficients together, the numbers together, and the variables. Notice that they're the same base together. Minus 8 times 9, 72, negative 72, because minus times positive is minus. A cubed times a to the 5th, 3 plus 5 is a to the 8th. So that the final result here is minus 72 a to the 8th power. Let's go one step more complicated and look at multiplying monomials with more than one variable. So here, in this case, we have added a b term in addition to the a term. And as your imagination might tell you, we can then separate them into the coefficients, the numbers, a's and b's. Let's see how we would do this. First, let's write these out as separate factors, since we're dealing entirely with multiplication. You might notice that that minus 2 coefficient in the second term, I've written with parentheses around it. And I've done that for clarity, because otherwise I would have a b times minus 2, and I would have two arithmetic operations right in a line. It never hurts for clarity to throw in some parentheses while you're working problems. It will help you to keep straight what the operations are and what to do, as I've done here. And then in the final answer, if you don't need the parentheses for clarity so people can understand the answer, you can remove them at the end. But I put them in now. Let's continue. I've written each of these terms out as separate factors. Now I can swap them around. I've put the coefficients in the front, 4 times minus 2, the a terms, then the b terms, and finally I can do the math. 4 times minus 2 is minus 8. A squared times a cubed is a to the 5th. B to the 1st power times b to the 6th power is b to the 7th. So the result of this operation is a monomial minus 8, a to the 5th, b to the 7th. We'll look at another example. Here we have minus 11, x to the 4th, y to the 6th, times a minus 3, xyz. First, we break it up into its pieces, and I use parentheses around those negative terms to keep them straight. Notice that I have put the coefficients all the way to the left, the x terms, the y terms, and the z term. Now I do the math. Minus 11 times a minus 3, minus times a minus is a plus. So I get 33 x to the fourth times x to the first power is x to the fifth. Y to the sixth times y to the first is y to the seventh. And I have the z by itself, so I don't need to multiply it by anything. It just goes down there since it's multiplied by the whole thing. I don't need to do any of the coefficient operations on it. The final result is 33 x to the fifth, y to the seventh, z. One more example, and it's a good one. Here we're multiplying three different terms together with q, r, and s in them, and in some cases there's an s term in one, an r term in the other. In other words, there are slightly different variables in each of those terms, but enough similar ones that we need to worry about it. So again, the first thing we do is separate out all of the coefficients. I'll go hunting now for q terms, and I see two of them. There's a q squared in the first factor and a q cubed in the second factor. Now I go hunting r terms. There's an r to the fourth in the first and another r to the fourth in the third. Finally, I'll look for s terms, and I see two of them, s to the sixth in the second factor, s squared in the third. Now I'm ready to complete the math. 4 times minus 2 times minus 5. Minus times minus is a plus. 2 times 5 is 10 times 4 is 40. Even I can do that one in my head. Q squared times q cubed is q to the fifth. R fourth times r fourth is r to the eighth. And s sixth times s squared is going also to be s to the eighth. To review, in order to multiply polynomials, you pick out the coefficients, put them on the right, multiply them together. Then look for variables of the same base, group those, and add their exponents, and you're finished. Let's look at how we would simplify monomials raised to a power. I'll tell you what that means. For example, here I have a cubed, that whole quantity squared. Let's see what we mean. Squared means that quantity is multiplied by itself. So if I have a cubed squared, that's a cubed times a cubed. 3 plus 3 is 6, using the rules we've already developed. Let's take a closer look at what happens here. A to the fourth power cubed. That's a to the fourth times a to the fourth times a to the fourth. Using our previous rule, it's a to the 4 plus 4 plus 4, or a to the 12th. In general, if you have a monomial x to the a raised to the b power, if you think about it, it's x to the a times b. So where you're multiplying two monomials, you add them. But if you have a monomial in brackets, and that's raised to a power, you multiply the exponents. Here's the rule. To simplify an exponential term raised to a power, you keep the same base, and you multiply the exponents. Let's look at some examples with this. How about 3x squared, all of that to the third power? Right now, just to see what's going on, and if you're ever confused, you can always do this. Multiply them out. So if you see something cubed, multiply it by itself 3 times, and then you can do the multiplications based on the rules you know. That's what I really like about math. If you understand what's going on underneath, you can always rely on those basic principles to bring you through if you happen to forget the rules. So in this case, suppose I forgot the rule that I take the exponents and multiply. If I'm taking some monomial to a power, I multiply the exponents. If I happen to forget that, I can just write it out as I've done here on the slide and then see exactly what to do. Using the rules we've developed for multiplying monomials, I can take the coefficients, put them over on the left, 3 times 3 times 3, and then get x squared times x squared times x squared, which I know how to deal with. 3 times 3 is 9 times 3 is 27. X squared times itself 3 times, 2 plus 2 plus 2 is 6. Let's look at another case. Now, the other thing I can do, if I have a monomial multiplied to a power and it has various factors in it, a coefficient and more than one variable, each one of those is individually multiplied to that power. So a minus 2 PR to the 5th power, that whole thing cubed, is going to be minus 2 cubed times p to the 1st power, or just p cubed, times r to the 5th power cubed. Minus 2 times minus 2 is plus 4, times minus 2 is minus 8. P to the 1 times 3, using the rule we're going to multiply the exponents, is p cubed. R to the 5 times 3 is r to the 15th power. Here's an application we can use, and it deals with distance measurements in units. And it's very useful in terms of areas or volumes or speeds or anything else. And it's this, that if you have units, you can treat the length or the width or any other unit or any other variable with a unit. For example, if you have 5 centimeters, or if you have 3 miles, you can treat the units, centimeters, miles, as if it were a variable, and then deal with it exactly as you would with a variable. It turns out that this is very useful. You can do math with the units exactly the same way you do math with the numbers themselves. And if you follow the math through with the units, the unit you should arrive at the end of the problem should be what you're looking for. For example, if you're multiplying velocity times time, velocity is in feet per second, time is seconds, so you have feet divided by seconds times seconds, you'll wind up with the unit feet. This is a way of checking your work, and in fact there's even a name for it. It's called dimensional, and if I could get it out straight, it's called dimensional analysis. Let's look at our example. Very simple one. Here is the area of a rectangle, and we know that the area is the length times the width. The area can be thought of as a monomial, 3 feet. If you think of that as a monomial where 3 is the coefficient and feet is the variable, we can do math just as we would with monomial. I can take the coefficients, the 3 times the 4 to the left, feet times feet to the right, and I get that the area is 12 feet squared, or 12 square feet. And since it came out feet squared, and I know I'm dealing with an area, I know square feet is an area, it makes me feel comfortable that I, for whatever reason, thankfully, have done the problem correctly. So coming out, if you include the dimensions in your math, coming out with the correct dimension is a great way to check yourself. Let's look at volume and see if it works with that. Here we have a box 3 feet by 4 feet by 5 feet. We know that the formula for volume is length times width times height. That's 3 times 4 times 5, feet times feet times feet. Treating this exactly the way we treated multiplication of monomials, we have 3 times 4 times 5 times feet times feet times feet. Doing that, 3 times 4 times 5 is 60. Feet times feet times feet is feet cubed, or cubic feet. This tells me that I have a good chance of having done this problem right if I haven't messed up the 3 times 4 times 5. Let's now look at extending what we've done with monomials to polynomials. So far, we've only looked at monomial terms, and remember, I was careful to tell you that when you're doing this, multiplying monomials, you have to be careful and look carefully to see that there are no additions or subtractions going on, because if you have monomials with a plus in the middle or a minus, other than a factor that you would have a bracket around, you're not dealing with a monomial anymore, you're dealing with a polynomial. We're going to look now at how you multiply polynomials where you have some monomial plus another monomial minus a third monomial, and we're going to take all that and multiply it by polynomials. We have to remember the distributive law, which we've discussed in the past, and it's very important here. If you have a quantity A times B plus C, the A gets distributed over the B and C. That's why it's called the distributive law. So the result is A times B, I have to multiply A by the first term, and you can think of B plus C as a binomial, and I also have to multiply the A times the second term. Let's look at our rule. To multiply a polynomial by a monomial, here's what we do. We use the distributive property to multiply each term in the polynomial by the monomial. We remember that's the distributive rule, and here's how we apply it. Just with numbers, if we have the distributive law, 3 times the quantity 4 plus 5 is 3 times 4 plus 3 times 5. I get 3 times 9, that's equal to 12 plus 15. 3 times 9 is 27. If I add 12 to 15, I also get 27. So we see the distributive law works for numbers. Let's look at it with variables. Here I have 8r times the quantity. Notice that there's a plus there, so that 2r squared plus 4r cubed is not a monomial, it's a binomial, which of course is a subset of a polynomial. I can't add those, I can't multiply it directly because of that addition term. Here's what we do. We use the distributive law, and I multiply both of those terms by the 8r. Then I simplify. 8 times 2 is 16. R to the first power times r squared is r cubed. Then I use the same sign that I find between the two terms in the binomial. 8 times 4 is 32. R to the first power times r cubed is r to the fourth power. Here's another example, a little bit more complex. Minus 4e squared f times the binomial 11e to the fourth f squared plus 2ef. I use the distributive law. First, I multiply that first monomial by the first term in the binomial, then by the second term in the binomial, and now I have to do 2 multiplications of monomials. Let's do that. I see minus 4 times 11 is minus 44. I have the e's by themselves, the f by themselves. I do the same thing to the right term. Minus 4 times 2 is minus 8. Then I simplify one more term by adding the exponents for each of the variables. I get minus 44 e to the 6th f cubed, and in this one, minus 8, 2 plus 1 is 3, 1 plus 1 is 2. Now let's try another one that's really interesting. We have minus 8 p squared q cubed r to the fourth times a trinomial. Let's multiply that. We use the distributive law, but now instead of having 2 terms, we have to distribute that first monomial over the 3 terms in the trinomial. Let's do it. We multiply by the first term and get that. We multiply the second term by the first monomial and get that. And finally, we multiply the last term and get that. Notice that as we do this in the trinomial, we keep the signs that are in the trinomial. For example, between the minus 6p6 and the 3p to the 4, I had a plus sign. So when I multiplied it by the first term, I kept the plus sign. Between the 3p to the 4th and the minus 2p squared, we had a negative sign, so I kept that. And that's the general rule for doing that. Now we need to multiply these things together. So we have minus 8p squared q cubed r to the 4th times minus 6p to the 6th. We multiply that, combine exponents, and get 48p to the 8th q cubed r to the 4th. Am I good saying that? Then we add the next term to it. Minus 8 times 3 is a minus 24. Therefore, we put a minus sign in there. And finally, we multiply out the last term. We have a minus, that's a plus, remember, and there's the last term. So this looked a little bit complex, but again, if you do this step by step, you're going to be in very good shape.